Welcome, everyone. It is 12 o'clock noon Eastern time, you know, the real time out here in New York, right? And today, Dorman training, we have network diagnosis. As we're going through, you could ask any question you want. We'll be dealing with, my name is G. Trulia, as you probably already know. What will be covered? Okay, you do have this handout, and I do want to remind you, everything except one thing, and it's only a class advertisement, numbered right here in the bottom right corner. So this is not the page number, that's the slide number. And we're going to cover networks, how they work, fundamentals of networks, twisted pair, system topography, protocol speeds, communication, tools to use. We're going to be using a bob. We're going to be using a meter, using a Labscope, and more. In fact, when we go over this way, you're going to see what we're using. We're going to have a Fluke meter. You all heard about when you're going to test a network, we're going to shut the network down. We're going to check ohm resistance and on what pins do we do it. So we'll use our meter for that on ohms. We're going to use the launch scan tool, which you can see a picture of right there, and the launch scope. So back out on that piece right there, we'll do an automatic search. And here's the launch Labscope. We're also going to be using the bob. Here's our bob. And you can see I have the key on because the first thing we'll use is the scan tool. You know, you want to do the easiest thing first. And if you can see the blue lights flashing, which I think you can quite well, that is CAN 6 and 14. And we'll talk about that. But we're going to talk about all different protocols. Not everyone's on a CAN system, right? There's still a lot of different stuff out there, like Class 2 and LIN. And let's go through and discuss it. So on a network, we got modules with a twisted pair. Why do we have a twisted pair? You know why we have a twisted pair? We want to keep interference down. Does that make sense? Interference down. So that's why we twist them. Network information, first of all, I call this the Automotive Bible. This is the Bosch Handbook. If you really want to know, oh, guys from Wisconsin, how you doing? Okay. If you really want to know a lot of different things, how the vehicle works, in here is everything. Networking. You have diesel engines, electric motors, gas engines, brakes, hydraulics, you name it. Go to sae.org, get this book, and you'll educate yourself. Version 10 currently. Okay. So communication systems. All electronic communication systems consist of three basic components, and that's important. A transmitter, something got to send a signal out. A communication channel, our connection right here, right? And a receiver. If you have those, that is going to be part of what a network is, right? So look without CAN. Without a network, you see all these wires, extra weight. Do you realize on a vehicle, there's over a mile of wires, and you heard me right? A mile of wires. 5,280 feet of wire on a vehicle, okay? Why? Because there's a whole bunch of electrical stuff going on. If we can reduce wiring, we can reduce the weight of the car and get more miles per gallon. And there's the difference without all those extra wires with CAN, for argument's sake. One type of a network multiplexer. And another look here, you know, we take a signal out of the VSS. Years ago, we needed to take that wire and go to the ECM, TCM, PCMs, you know, the body control module, wipers, audio, cruise control, all that junk. Look what you do now. One goes in, goes to the ECM, PCM, and gets shared on a network wire. That's a lot less weight and a lot less problems to happen. Okay. Twisted pair. This is important. I want you on slide 11. You see this one twist per inch. One twist per inch to keep out the electrical interference. Very, very important. Okay. So a twisted pair is wiring where two conductors of a signal circuit are twisted together for the purpose of improving electromagnetic capability. Twisted pair, reduces electromagnetic radiation. Radiation means noise from the pair and crosstalk between other pairs that improves rejection of external electromagnetic interference. Now, here we have an example of a splice pack. So right there, some vehicles don't have splice packs, most do, but if it don't, then you got to disconnect modules. Now, let's take this example right here. You can see the splice pack in this wiring diagram on this GM vehicle. You have different things that are in this splice pack. So you could have OnStar, for example. You could have the airbag, driver information center, instrument panel, radio, CD player, and more. So let's say you had a problem, okay? If you had a problem on the network and you pulled the comb out and no longer have a network, how do I find out where I have the problem on the network? We would then get a jumper wire and jump it one at a time to see if that particular one is bad. They do make a set of wires that you can plug multiple in. You go into one and then you could go out and do 2 or more computers. Okay, we got a couple of questions.
Can you extend a twisted pair?
Could you extend the twisted pair? Yes, you can. An easy way to do that is take the same gauge wiring, make sure that you connect them together by solder heat shrink, and take a drill and basically make sure you got at least 1 twist per inch. Any other questions?
Yes. How do you tap into a twisted pair for testing if you don't have a box?
Well, tapping in is not a good idea on a network. You would have to go to the end of it, the termination thing, and put back probe pins in. So you have to go to a connector. Don't go in and pierce any wires. So a couple of good questions there. So here, again, we can use different jumpers to find out where it is. And obviously, when you jump the one, I'm going to say like the radio is bad. Okay, so now you take the radio off the bus, put the comb back in, right? Here's our comb. Plug the comb in. Now everything else is working and the bus is working fine. You're going to need to take care of that radio or infotainment center. Okay, let's look at Class 2. Class 2 has been around for years, okay? Highly used. And Class 2, we can get a voltage like this. We can go to a good ground and pin number 2 of a 16 cavity connector. Pin 2, okay? So serial data used on many GMs, okay? It transmits on a single wire at 10,400 bits of information per second. Variable pulse width signal, so it's VPW, okay? And it's a 7-volt. Highlight that, circle it, write it down, whatever you got to do. 7-volt signal that uses an average voltage. What does that mean? Average of 7 is going to be what? About 3.5, right? It's not that hard. And it uses a floating bus. What's a floating bus? Well, you know, if we go back to Bob over here, I want you all to write this down. So, pin 4 is chassis ground. I think it's better that way, right? Pin 4 chassis ground. Pin 5 signal ground. That means it's an elevated ground off the chassis. What's an elevated ground mean? If this is 0, it's going to be up. Okay, it could be a volt, 2 volts, depending on the manufacturer. It could be millivolts. Now, I know we got a couple of questions before we go forward. And you can see while she's getting ready to read me the questions, there's our floating bus from 0 to 7. And if we use a meter, if you don't own a scope, you're going to average the top, which is 7 volts, and the bottom that is 0. You're going to be roughly about 3.5 volts. Questions?
What's your opinion on the solder heat shrink combos?
We use the solder heat shrink all the time. We use a Milwaukee gun. We used to have the wired one, but now we use a Milwaukee battery operated one. You got to use the deflector shield. Make sure you go on the solder first. And it's a good idea to have some of that aluminum type of foil. You can get it in Home Depot. It's insulation, because you do not want to take a chance of melting any of the wires. So we use it all the time. We buy the stuff through Napa and other companies And I think that's the best way to go nowadays.
And do the wires need to be shielded?
Do the wires need to be what?
Shield?
Shield. If there's shielding on it, you're going to need to connect shielding. Now when shielding breaks, it's like your coax cable for your TV. That could be a little dicey. You would have to get, because you have a wire in the middle, right? And then you have all that, you have insulation, you got the shielding. You're going to have to connect to that shielding and go to a ground, okay? So sometimes that's difficult. You may have to take that braiding, twist it together, and make sure it got a good connection, go to ground to keep interference off it. So let's move along here. Now when you look at these meters, here's real problems that happens. Here's our average of 7 volts. Look at that. 3.45, 3 volts, 450 millivolts. But what happens when we have a low voltage like this? Well, when the bus is low, what does that indicate? That indicates you probably have a short pulling it down. So if you get a code for circuit system low, okay, circuit system low or circuit voltage low, guess what? That means you're pulling down that 7 volts to a lower one, and that's what we have here. Now, conversely, if we have circuit voltage high, you could have a short to power or an open. In this case, it wouldn't be a full open. Why? We only have 5 volts for 140 millivolts. Now, that could also be a poor ground, right, if you can't pull 7 volts. But why are you not averaging it? So the real thing here is 5, it's averaging over 10 volts. You probably got a short to power, like that one is an example of. Any questions on that? All right, I will move along here. Let's go look at a case study. This vehicle came in the bay right next to where I am, actually. So this is a Class 2 2012 Chevy Colorado 2.9, and it had a stability track issue, an ABS message displayed on the dash, a U1000 Class 2 data bus code, ABS and instrument cluster, and voltage codes in the BCM and TPMS. So now you look up the codes. You always want to RTFI, read the frickin' information. Why? Because that's going to tell you where to go, and you're going to see what I'm talking about, okay? Research in the system showed us that the BCM monitors the voltage over multiple modules and is also known as a common hub. So the BCM is the hub. Hey, we all send our messages in there. For most of the modules on a Class 2 bus. Test powers and grounds, they all checked okay. Now, just like I wouldn't drive to here, to Wisconsin or California or Alabama without consulting a map or GPS, right? The wiring diagram is the map of the system. So let's take a look at the map of this system. I got to blow it up. We look at it and we see on a Class 2 signal, I'm going to blow this up because it'll be a little easier than me magnifying it. It basically tells us the transfer case, okay, the module is under the driver's seat. So why did we go there? Well, we looked at the system, looking at the wiring diagram, traced the voltage, right? Traced the voltage out, and where's it at a range? It could be at the transfer case, and you want to go to the easiest place first. So what did we do? We took a look under the seat. Why do you look under seats? Well, you've all seen this. People leave their windows open, water gets in, they spill soda, they spill coffee. So let's take a look. But before we looked under the seat, we hooked up our scope. We connected a lab scope at the DLC. What pin? Write that down. It's not there. What pin? Pin number 2. Why pin number 2? Because that's Class 2 voltage. They put it in 2. Easy to remember. Class 2, pin 2. Okay. The data bus and found a 0 to 5 waveform. The voltage needs to be 7 volts. Something's pulling it down. Does that make sense? So something is shorting it. Went to the next easiest module, ABS, scoped both Class 2 wires at the module, and here's what we found. Look at this. You can see we're not all the way down to 0. See, this is a floating ground, not all the way down. We're up about 300 millivolts. And look where we are here. We're not at 7 volts. We should be. We see a packet break, and look at this. We see a big hole going down the ground. So you got a problem going on for multiple reasons. What are the multiple reasons? 1, we're not reaching the voltage height, the amplitude. 2, we're really not getting a lot of good packets here. You don't want a whole bunch of stuff. It's trying to communicate. You see the breaks and a lot of yellow, more yellow breaks, and they're not going all the way down. Notice how they're not being pulled all the way down, like here in this example. You see how that's going all the way down? But it ain't going down where we need it to be. We need 7 volts. Found the break in the data along with 2 different voltage ranges in the wire. We look under the seat. You see this is all wet? Oh, the guy even has a little bit of a rapid air from a candy bar or something. This took water on. When things take water on, it's like my upcoming motor age article. There'll be some, it's on euros, but it's the same thing. It's on a communication system. Always clean drains out in vehicles and moonroofs. Make sure you open them up, trunks, clear all that junk out of there. We have vacuums here in every bay. I put that in the article, air vacuums. Get that junk out of there because the water will go in like it did here, and guess what? Of course, we have to dry it up, find the source. There was no leaks on the gaskets. We took the truck outside. We put a hose to it. The guy must have left his window open. Who the hey knows? That's what happens sometimes, right? So that's what fixed it. Let's look at more communication stuff. There's the pin. You see pin 2, VPW, also used on J1850, pulse width modulated. And if you have CAN, you need pin 6 and pin 14 must be in there. So here's our 16 cavity connector. Not all cavities will be filled. Not all cavities will be filled. Here's a non-CAN system. Look at all that stuff going on. Look at all those wires. It's slower. It's not going to go at a higher speed. We're going to talk about speed in a minute. I'm not going to waste the time here, but we'll talk about it. We're going to go live on the car. I'm going to show you how to check the system, okay? And look with it here on 6 and 14, a lot less wires, higher speed. You're talking about, without it, maybe 12,000 bits of information per second. With it, 500 million plus bits of information per second, meaning it's a lot faster. And here's, we got CAN C, CAN B, and CAN A. CAN A you're not seeing here. So what else we got here? ABS, PCM, SIR. What else would be for a Dorman t-shirt? Okay, for a Dorman t-shirt, what else would be on today's vehicle on CAN C? First person, CAN C. What system would be on it that is that important? Anything that needs high speed cannot be, no, PCM's already on there. Huh? That's the airbags, that's already on there. Navigation, no. ADAS, whoever said ADAS, put in your email. ADAS, very important. You're coming up to a vehicle.
That's Darren.
It's going to slow it up. Darren, put your email in there. We'll get you a Dorman shirt out, okay? So when you guys are paying attention, we like that. We got some stuff we'll give away, okay? Very good. So that's where you would have ADAS. Because think about it. You don't need a lot of speed for maybe your trunk lock. That could be on Class A. Does the trunk need to open super duper fast? No, you press the button, boom, okay? But your PCM, your TCM, right? It needs information. ADAS, airbags. You don't want your airbag going, okay, I think I got to take a sip of water over here, and I'll decide when I shoot the airbag out. Well, if it's that slow, you're going to be hurting puppy, right? Because the airbag's not going to protect you. So here are the different Class A low speed under 10,000 bits per information with a rate of message is 100 milliseconds or less, or 10 messages per second. Class B, medium, 10 to 125,000 bits, maximum rate about 20 milliseconds or 50 messages per second. CAN C, high speed, Minimal 125,000 bits, 1 million bits, maximum rate less than 5 milliseconds, 1,000 milliseconds make a second, 200 messages per second and then some. And Class D, high speed, 1 million to 150 million. Example, the Ethernet, so like you plug into the back of your computer, X-Wire, FlexRay, CAN. If you were on one of our Dorman Lunch and Learns, and you could see these, when we were on the Tesla, Tesla is using an Ethernet wire. So the same thing that plugs in the back of your computer is going into the car. Now, BMW, Mercedes, Volvo, they've all used that before. Why? They got so many onboard computers, they needed to get the speed in there so they could, what? Program their computers, see what information's coming out. Your scan tool could only move as fast as it can. It's like a big funnel. All the stuff is coming in quick, and then it has to slow up for your scan tool. So your scan tool is not giving you that rate of data. It's giving you faster data, but not that fast. Here are bus topographies. There's master. Master means you got one main one and goes around. There's round robin or token. They're all in this type of configuration, or arbitration, where you have a master, slave, and they're all going back and forth with each other. That's called like a tree topography. Pretty common out there. And vehicles have several different buses. High speed will be used on systems that need it, such as engine trannies, airbags, and ADAS and so on. Low speed will be used on systems where speed is not needed, the seat, the door, and you can see here. Now, how about this thing, a gateway module? What vehicle do you have issues with communicating because of the gateway module? What year did it start? So you could be on a popular brand car manufacturer, and the issue you have is when you plug your scan tool in and you didn't go to www.autoauth.com to register your tool for 50 bucks, and any scan tool that goes online that's aftermarket, guess what? You're going to need that because they'll lock you out of that gateway module. And more vehicles still coming. Nissan and Infiniti on their factory tool lock you out. And GM and all these other companies are starting to do it. So be aware, go to autoauth.com. Anyone answer that question correctly?
I'll tell you the answer soon.
So what company, what year? Company and year.
I have GM, I have 2018 Dodge,
Nope.
Chrysler, 218 Jeep, Chrysler,
Nope.
VW,
Nope.
218 Chrysler Products, Nissan.
Okay. Nissan, we already said is correct, but here's what you want to write down. 2017 and up, all Chrysler, Stellantis products, Jeep, all that junk, okay? Dodge Ram, all of it. And I don't mean the car's junk, unless you take it that way. Okay. All right, now CAN priority. So vehicle speed, knock, RPM, and oil temp. The scan tool goes in, but the scan tool is the lowest priority, right? The CAN transceiver will set the priority for outgoing messages. It says, hey, this thing is not as important as me giving the vehicle speed to the system. That'll make the transmission go, that'll make everything go. To wake a bus up, if you open the door up, you're going to see that in a little bit, or if that don't work, you put the four-way flashes on. Slide 30, please circle that. Some people don't know that. Slide 30, please circle that. Four-way flashes going on and off will wake the circuit up. Here's our LIN system. LIN is a system that goes where? To 12 volts. And you see how we got packets, then we got up and down, we got packets, you got a space. This is communicating some sort of information, and it's a floating ground. Here's 0. It is not all the way down, it's going from 1 volt up. Why do they do that? If you put the right answer in, you will win a Dorman t-shirt. Why do they have a floating ground? First guy. Now here is CAN Class B, a wake up. So what's a wake up? You remember like putting the four-way flashes on and unlocking the door? Look where the voltage went. The voltage goes up to 12 volts. And then you see how the packets are moving? And on this system, we're about 300 millivolts, and we're roughly a 5 volt signal. Now, you remember class 2 was 7 volts, LIN 12 volts, CAN B 5 volts, plus there's others out there that we're going to look at like CAN. So here, we're going to do this on the car. I'm going to shut my mouth in a minute and get to the car. But CAN uses a 5 volt reference. So pin 6 is about 2.5 volts to 3.5 volts. Pin 14, and that's CAN high, pin 14, 2.5 to 1.5. Perform voltage with a voltmeter or a Labscope. Labscope preferably. CAN either serial or parallel, and this is important, we'll have 120 ohm terminator resistors. So you're going to have at least 2 of them. Divide them in parallel equals roughly 60 ohms. Here's how to do that, because not all systems, unless they're CAN, will have 120 ohm resistor. So 1 divided into 120 equals 0.08333 or 0.08. Next, add 2 terminator resistors together, because there's 2 120s. That's going to equal 0.016. Followed by divide 1 into 0.016 equals 0.0625 or roughly 62 ohms or so. Always perform the ohm test with the battery disconnected. So let's go over and do that. Well, the battery or the system, I want you to look. You see how this thing is plopping around, right? You see how this thing is moving? It's up and down. I got to shut the key off, or the power button, I should say. Just don't have a key. So I'm going to reach in, shut the button off. You got an answer, you said? What's the answer?
Interference?
Nope, not correct.
I got several.
Okay, Doreen's going through several answers.
Test circuit?
No.
Interference, test voltage drop, fault tolerance because of OV, 0V is fault.
Okay, well, you know, we don't have a lot of time, unfortunately. I'll look through the answers. If we find someone did the right one, we'll contact you. Okay, so now you see how this is communicating? It's still beeping. It's not going to sleep yet. I'm going to unplug these leads. I'm going to take my meter leads, okay, and I'm going to put my meter on ohms. I'm on the ohm scale. I am going to take the leads and put the red one in pin what? Pin 6, and the other one, the black lead, in pin 16. Now, since the bus is still active, you see that? Could they see the number? Oh, the stupid leads are right in my way. You see the numbers still bouncing around? We got to wait for this thing to calm down and go to sleep. So that may take a few seconds. We're just going to leave this over here. I got to make sure that key is off. Yes, it is. Oh, nope, I still see the dash on. So I got to make sure it's off. There we go. Now it's off. We're still blinking. And you're going to see it's going to take a little bit to go to sleep. Could they see those numbers pretty good? Yeah. And I'm going to get tired holding this, but it will go to sleep. I'm just going to leave it over here, so no one's going to touch it. And when I see the lights that stop flashing, I will come back, because we do only have about an hour or so, right? And I see the numbers going down, but still going. So that's basically what we're doing with the famous box. So CAN C, testing at the DLC, will not always test the CAN system, especially if there is a gateway module. And this is the Chrysler topography. If we have a gateway module, we won't get to it. Example to the right, a 2017 later FCA, or Stellantis nowadays, scan tool connected, is will prevent you from clearing codes. Bidirectional control. You need to go to auto off. This is line 34, so if you didn't write that down before, go to auto off. Okay, that will be real good. Up, come back to this. It went to sleep. Follow me back here. Follow me back. Look at this. Where's our resistance? No lights flashing. 61.3 ohms. Now watch this. I'm going to touch the door lock. Can they see that? Yep. What just happened? Do you see the bus came back to life? Do you see these blinking? So you don't want to test it with the bus on. You want to make sure it goes to sleep. And this will take a few seconds to go down. We're not going to waste the time here because we got to hook a scope up and a scan tool and take it from there. Okay. And while we're on that, why don't we go to the scan tool real quick so we can get that up while it's doing a test. Here we have the Launch tablet. This is a great tool. We're going to do auto search. We're going to read the VIN. And I got to put the key on because it won't work if I don't put the button on. And when I say the key, guys, I'm talking the, I got to open the door. I can't reach it. And by the way, when you have these buttons in a car, you got to hold the button down for a while if you're not used to that. I still come across some guys in classes that have that issue. I'm going to shut my ohm meter off because we won't be using that anymore. I'm going to take my scope leads and put them here. Same place I did before. I'm going to go into 6 and 14 with the scope leads. The bus is alive, but I am going to check out the scan tool. So watch what I'm going to do on the Launch scan tool. This is great. I'm going to do a health report. It has topography. So right there, there is a problem. There are two problems. So this is something on the bus. And then we're on a 2013 Chevy Volt. This has a extended range type of vehicle. It has a gas engine, and obviously it has electric motors. So when we look into this, it's going through all the modules, and we're going to see if we have anything else that comes up with a problem. So it looks like it's almost done scanning. You can see the red bar. And if you have any questions, type them in there now. I'm going to take a look at them before we move on. So as that's scanning through, okay, floating ground, kept out the interference, floating ground. Okay, Keith DeFazio.
Was Keith said interference earlier?
If Lynn is pulling down to 1 volt, you can identify. Okay. All right, we got to go, you know, in the sake of time, we'll go back and look at that. Some of the comments are correct. Okay, so we got two problems here. So we can go into the ECM. You can do what they call a code search or a code fix to get in what that problem is. You could also do that on the other one. And if you go into this, notice the high voltage battery system isolation fault and system lost. So you can do code search, goes up and gives you stuff on the internet. Okay. You can go fix, and the fix will go in and give you the information right from Launch, which is pretty cool. And it will tell you where's the results. You got technical service bulletins, pulls it right up. Pretty neat, right? That's pretty neat stuff that if you go in, you can pop it up and you can see vehicle will not charge, hybrid system isolation fault. It gives you all the information here. condition, cause, correction, okay? All that information right there. So we're going to get out of that for now. And we are going to go home and we're going to quit. I'll clear the DTCs real quick. And as that's doing a clear, we'll get back to the slides because, again, in the sake of time here, for an hour. All right, so terminator resistance kills noise on the circuit. If there are no bus voltage readings on a DLC for the CAN bus, go to individual modules. Disconnect the wires, KO-EO. Connect the meter or Labscope in series. If you can't find a network problem, try disconnecting one module at a time from the bus. Remember, if it has a comb, you disconnect the comb, okay? But sometimes they don't have combs. Always disconnect the battery when performing the ohm test. We went over that before. And this is all bus ring-in. Bus ring-in means you have a terminator resistor that is not good. So you may want to write that down. When you get bus ring-in, you have a terminator resistor that has a problem. Now, when you look at Class C, you do have other resistance. You can see 3K, 3,000 ohms, 1,000 ohms. There's all 120 for CAN high, CAN low. So always look at information. Let's take a look at this vehicle we had here. And this Tundra came in from another shop. No start, no communications. But you know what they told us? You know what they said? They said, program it. It's going to fix it. Now, you know, I was just out in Oklahoma with Keith Perkins. Sorry, Keith DeFazio. You're in North Carolina. With Keith Perkins, and we were discussing this, how when other shops send you stuff, they think programming is going to fix everything. Not so. You need to do your due diligence, right? RTFI, read the freaking information. Let's take a look after you do the look-see. You know what the look-see is? God gave us the best tools, the brain, the eyes, ears, the nose, the hands. You need to use them, right? We can look up in all data. ProDemand, Identifix, Motologic, right? We need to use all the tools we can get. Yes, diag.net, IATN, Google, and even YouTube, right? Of course, there are some good people out there. And of course, there is some, got to pick the pepper out of the fly do, right? There's some garbage out there as well. So here, with a look, we see this no start, no communication, an open broken wire to a shorted air pump. So the air pump was shorted. The hose, water usually gets in there. We found a lot of these. Another little tip you may want to write down. When the air pumps are starting to go, you're going to have a bunch of lights on the dash, like traction control, ABS, sometimes four-wheel. A bunch of lights going to be on the dash with a bunch of codes. You need to check the AIR system. You would go, what the hey does that have to do with it? That's why you look at a wiring diagram, right? Not because I told you that's the problem. That's a big issue in our industry, and I'm preaching to the choir here, where people want a quick fix. A lot of people call me up, go, hey, I'm working on this car, but what did you come across? You got to do your homework, right? You got to do your homework. So here, we wanted to load test the circuit. How many guys do this? Forget about taking your meter and saying, do I have good power and ground there? I got 12 volts. 12 volts is not a load. We put a headlight, 5, 6 amps. If it can light it up, that circuit is good. Does that make sense? Okay. So what we needed to do here, excuse me, load test the circuit, make sure it can carry it. We fixed the wire, recommended the air pump. The shop, I don't think they replaced it. Of course, it was never going to pass the New York State inspection, but that ain't my problem. That's his problem. And we replaced it. The pump was pulling too much amperage, so we had to leave the pump disconnected. Does that make sense? Okay, disconnected. Let's go back and see what we're at over here. Okay, we're all clear. We got no problems. We can charge this up without an issue now. We're going to go home. We want to quit this. We want to go into Labscope. And I had set this up because of time. We're on our Launch Labscope here. This is a 4-channel scope. This is the box for it that connects into it. One thing I suggested to Launch, it's a real nice unit. And you may have seen the sensor simulator webinar we did, and I happen to use this as well. If they allow us to see 2 screens or 3 screens, you know what I like to see here? I like to see scan data, and I like to see the scope. And if I'm using a sensor simulator, I'd like to see all 3 of them. And I think they're working on that. I'll be meeting with them out in Las Vegas. So now we see our box going back and forth. And if those packets, you can see them moving across. These are the lights here. Go back to the scope. And watch the communication. You see packets just changed there. You had a big opening. Let me put my foot down on the brake. Another packet change. Let me do a startup. Now you hear a gas motor running because that's a safety feature here on this particular vehicle. When the hood is open, high voltage will be shut off. Shut it down and just leave the key on and see communication packets. Now, if we're not going down or reading the right voltage, then we would see we have a problem. This does not have a problem with the network. Does that make sense? This does not. Here we're using a picoscope, and you know, a lot of people, this is a good signal on CAN here. We got CAN high, and if you look at the voltage coming across, you go across here, we start at 2.6, and we basically up a little more over 3.6, right? We could look at your measurements there. You see the red, you come across on the bottom. We're basically down here at probably 1.6 or so, and going up. And all of the packets are all individual. You see little packets coming here, and then it spaces. They spaced out a little differently. Now, a lot of people, when they see this, when they see a anomaly, something shooting down, they go, oh, I got a problem. That's not what a problem is going to be. A problem is something like I showed you before, okay? And when I showed you that before, you know, you needed to look at that very carefully. So we're going to go back for a second just to look at something there. So remember the CAN voltages right here? Where are the CAN voltages at? 2.5 to 3.5 and 2.5 to 1.5. Those are both your CAN high and low, right? So let me see some questions we had here. If we can scroll, disconnect the battery, just wait for the bus. Okay, so good question there. Should I disconnect the battery or just wait till the bus to go to sleep? I'm lazy, especially in a webinar. We'll just let the bus go to sleep. Whoa, whoa, don't move that fast. Okay. Start from the bottom and it'll just go up. Thanks. Important of a mirroring signal, yes. So Keith says, you know, the mirroring signal, whatever you see up top, just like, where's my clicker? Just like we see there. Could we hit to the slides for a second there? So that's good. Just yesterday I had a 2009 HHR. Wow, that's a problem in itself, Darren. With no crank issue. That was communication issue on ABS. Okay. Okay, I can't read that fast when you do it. Floating ground allows for accurate ground on all loaded circuits. Yeah, so let's talk about that floated ground again. A floated ground, when you crank the car over, we all know 12 volts is going to go down to 10 volts or so, right? Maybe, you know, if you've got a really good system, maybe just into the 11 range. But we're pulling on the ground, the chassis ground, right? We don't want something that has to be so accurate being pulled on. So what do? They raise the level. Give you another example. Have you worked on Chrysler products, the Olympus products? Go to the oxygen sensor wire, go back probe the oxygen sensor wire, and if you're on chassis ground, you're going to read 2.5 to 3.5 volts. And you're going to go, what the hell is wrong with that? Now remember, that's a four-wire connector. The other thing that didn't work there for a second. We got a ground for the heater, a 12 volt for the heater, a signal ground, pin 5, right? And then what do we have as well? The signal wire. But if I go from a good ground, usually the battery ground, right? And I go to that signal wire, I will read 2.5 to 3.5 volts. If I switched over to the signal wire or pin 5, I would read 0 to 1 volts. So that's a floating ground. We don't want to pull down on it. There are many companies that do that. Let's see what else we have there. I think we're pretty good on all those questions then. Okay. The handout, where can you get it? Should be right there to download right on the side. If you still don't have it, you could email us and we'll make sure we'll get that out to you. Also, when I put the recording up, I will basically have that, handout right there. Anyone have any other questions on the system? Remember, you know, when you're working on a vehicle, just like that gentleman that was working on that vehicle yesterday, the HHR, you're always going to use the easiest thing first. You should always do the visual inspection and all that. How many times have you found a problem by looking, smelling, seeing, hearing a problem, right? Many times. So after you do that preliminary check, plug the scan tool in. If you have a network problem, you're going to see it. Now, 2 aftermarket tools have this topography. Launch does a real nice job here. There's also Autel, but we use a lot of factory tools here. So the Chrysler factory tool, YTech, we have the BMW tool, ISTA, we have Otis, that has it. Now, you know, another thing, you go, well, I don't have all those tools, but here's something I do want to recommend to you. We have it and beta tested it from the beginning. You want to get the Opus IVS. You've heard me say this in other ones. No, they're not paying me to say it. The reason why you want to get that, if you need a factory tool, you're going to need to basically get that. Launch does a great job on tons of domestic, Asian, and Euros, but sometimes you may need the factory tool. And if you're on Otis, for example, if anyone ever used Otis, it's not an easy tool to use. So with Opus, and I think Keith still works for Opus, okay, they get an expert on your tablet, and they're going to use the factory tool to diagnose and help you fix that car. That's what you're paying for. So roughly, and again, this is probably not 100% right, but people always ask me in classes, how much is that roughly? It's about $6 grand, $299 a month. You know, if Keith wants to pop in some other answers there, that'd be great. Look at what he's saying there, or Doreen will read it to me. But roughly, it's about that amount. That gives you a lot of access to factory info and asking like your buddy, right? When you ask someone help, like if we put all our heads together, the people that are on this webinar, we could diagnose and fix a car quite easily. That's the beauty of Diag.net, IATN, your buddy in the next bay, and the Opus IVS team. You're not buying their scan tool per se, because it's not a scan tool. It's a system with diagnostic support. Now, Launch also, as you've seen here, has some neat stuff in there. They also have some remote access things. But that's my suggestion if you want a factory tool and you can't afford it. I'll be honest with you. If I didn't purchase all those factory tools already, We got GM, Ford, Chrysler, Toyota, Honda, you know, BMW, Mercedes, Volkswagen, Volvo. That's a lot of money. I wouldn't buy all that stuff and a few others. I would just buy that tablet. You know why? How many times do you need to pull it out? Never take the backhoe out if the shovel will do the job, right? So I'm not pulling a factory tool out all the time. We got loads of laptops in this place and tablets. And if you're going to do that, rather than just taking this out where it's pop a button on and I'm into the car or vehicle, 9 out of 10 times you're going to be okay. Okay. So there's a suggestion to build your diagnostic game plan that I always talk about. You need a plan. Fail to plan to fail. That's like our Jets and Giants, right? No plan and they fail. Okay. So anyway, there's our CAN signal, good up and down. Any questions or comments that I need to address?
He said it is $5,000 and $299 a month, unlimited access to tech support with factory trained technicians available.
Okay, so thank you, Keith. So now it's $5,000, $299 a month, and you have unlimited, and that's true. You could ask them. You know what I like? You press a button, they get to a tech support guy.
Also, the techs are willing to help with any device you own.
Yeah, so they're pretty good. I know they can do picoscope, a Bernie scope, or a different scan tool you're on. If they're familiar with it, they're more than happy to help you out. We've done some stuff here that we had an infotainment system take a bus down on a 2022 A6 Audi, okay? It was bad. You know, we replaced it. One of my techs, I think Bill actually did it that day. But we were so busy to get caught up on other work, we had Michael, who was our apprentice, didn't know a spoke on a wheel, okay? I'm not kidding you. But we told them to follow the prompts when the guy told them to do something. Put a battery maintainer on. He was able to do that. Pressed his button. Walked them all the way through it, programmed the vehicle, and you know what? It was worth it even though we had Otis to do it. Because that means one of us has to get off something more important that we can make more money on. You know the old adage, it takes money to make money. So what do we mean by that? Well, I got to pay Opus an additional charge. I forgot what program it is, maybe a couple of $100. But you know, if it's $100, $150, $200, who cares? The car's not leaving your shop. And you're getting the work done rather than sending that customer's car to somewhere else. So very important to make your game plan, have your tool, you know, like with the launch stuff, we use that a lot. We also sometimes use Snap-on, but this thing is very reliable to go in. You've seen what it did with the topography. 1, 2, 3, we got all other tools, Snap-on, Autel, Top-Don, you name the tool, I got it, right? But this is quick, easy to update, easy to operate, gives you good info. That's the name of the game. When you're past that, that's when you get the Opus tool, okay? So anyway, whoa, got a little flying bug around here. So here's a little bonus. This bonus right here, we had a late model General Motors vehicle in. Now having the GDS software, you know, before you'd be able to get in, and this was a 23 GMC Sierra pickup, was smacked up. We got it from the body shop who fixed it. The owner of the vehicle asked the body shop, hey, can you put fog lights? I didn't buy it on the vehicle, and I really want those fog lights. They ordered them from GM, put them in. They didn't work. That's right, they didn't work. Why? Because it's somebody new on that bus, and it needs to be programmed in there. So we told them, yeah, no problem. Just bring it over. We'll get this thing done, 1, 2, 3. Well, it wasn't 1, 2, 3. And, you know, every day you learn something when you think you know everything, and I surely hell don't, right? But I know a lot. And I said, you know, many times before it was either in the scan tool part or when you went into programming, you could simply program it like a piece of cake. Go in. We went in. We found nothing in the scan tool, nothing in the programming. So what did we do? We reached out to AC Delco. Here's the number you got to call, 800-223-3526. You got to provide them the VIN number. Now, in many cases, if you replaced a module, they're going to want the customer info. They did want the registration. Thank God that was in the vehicle. And, you know, they did not ask us to get a customer signature. But if we did replace a module, then they would have wanted that. They turned on the component in the software. So what they did is they said it's going to take a few minutes, go back to the BCM programming, and you're going to see on the list that there's a thing for fog lights. We pressed the button, we allowed the BCM to accept the component, and the programming was normal after that. That's pretty simple, isn't it? So a lot of times, and each manufacturer may have something a little different, you're going to learn something new every day, okay? So if there's any questions, get them out there because we only got a couple of minutes left here. If you didn't see our heavy-duty Lunch and Learn, that was yesterday. Both of these will be up on the Dorman website and for now on the ATTS website under Dorman Lunch and Learn, and the heavy-duty on the Lunch and Learn HD. Probably by the end of the day, both of them will be up and available, okay? So if you're interested from Dorman and ATTS here for a hands-on hybrid EV class, we still have a few seats left. It is coming up on Thursday. It starts November 16th to Sunday, November 19th, 4 days. We cover from a hybrid right up to an EV, okay? We talk about the charging of the electric vehicles. We'll talk about basically how to test a motor, how to use a megometer, a milliometer. You get good hands-on experience. The last class, we had the Navy back in to train some more of their guys. So if you're interested, here's where you go sign up. Sign up at dormantraininglive.com or attstraining.com. That'll take you over to the Dorman site. Well, it's about that time, and for Dorman Products, I want to thank you for coming out. We do have something new now, the QR code. If you thought this was helpful, you could type a letter Y in. If you thought it stunk, type a letter N in. So Y, it was good, and it's no good. And we want to thank you for coming out. We'll see you next month. Have a great day.